So the next lesson is about hypergeometric distributions. So hypergeometric distributions that actually have very similar properties to binomial. There are a specific number of trials, and you want a specific number of successes. There is a probability of success and a probability of failure. Okay, so both of those two criteria are true. The one thing that is different is that the events are going to be dependent. Okay, so if the outcome of the first pick affects the outcome of the second, and so on, those are dependent events. And when they're dependent events, it's going to be a hypergeometric distribution. Now, the formula for this one is actually, it looks fairly complicated, and I would honestly recommend not using the formula, because we've actually been doing hypergeometric distribution questions all this time in the combinations unit. We just didn't call it hypergeometric. Okay, so you're more than welcome to use the formula, but it's not necessarily, I won't ever ask you to actually write it out. So here is that formula. So the formula for hypergeometric, P of x, is equal to A choose x times n minus A choose r minus x all over n choose r. So n stands for the total number of possible outcomes. That's really total options. So that's all the possible things that you could choose from. A is the number of successful options. That's how many things you want. It's the number of possible things that you could choose from that you actually want. X is the number of successful outcomes. That's how many you want to choose. And R is the number of trials. That's the total number of items that need to be gathered all together. Okay. And just like before, there is a specific expected value formula that goes along with this. It would be R, so the number of trials, or the number of things that you're choosing, times A, which is the number of successful options that you have, all over N, where N is the number of possible options. Okay. So, as I said before, I wouldn't recommend memorizing this formula. I would just do the question like we would have in the combinations unit. So let's actually go through an example and see what I mean by that. So here we are choosing a jury of 6 people from 10 women and 8 men. What is the probability of choosing X women on the jury? Okay, so we're actually filling out this table here. So X could be 0, 1, 2, 3, 4, 5, or 6. And you're going to have to do this calculation for every single possible X value. So we're actually going to do this calculation 7 times. I'll do the first one with you, and then I'll have you do the next 6 yourself. So the first one would be, what's the probability of choosing 0 women? Okay, so that would be the number of no women committees over the number of total committees that are possible, right? That's how we would do the number of no women committees. So if we want no women, there are 10 possible women. We are going to choose none of them. And if there's no women, that means that all 6 jurors have to be men. So there are 8 men. We choose 6. Okay, and then that's all over the total number of people, so 18. Choose the total number of items we need to choose, which is 6. Okay. This actually does exactly follow that formula. It's just that we didn't really need the formula to do it. Okay. And we could work this out now, and it would be 0.0151, and we would write that in our table. Okay. And we now need to repeat this to get the proper probability distribution for the next 6 items. So pause the video for a second, and I will write out the first one for you. So here's the probability of getting exactly 1 woman. So in other words, X equaling 1. we're going to do 10 choose 1, so 10 women choose the 1 woman, times 8 choose 5, so the 8 men choose the other 5 jurors, all over 18 choose 6. Okay, so once again, pause the video, give the rest of them a try, and then when you unpause it, they will show up in the table for you. And there we have the full filled-in table that you can check your answers against. So that would be the probability distribution of choosing X women on a 6-person jury. What is the expected number of women on this jury? Okay, so if you think about this, remember the expected value formula was RA over N. Or you could go back and do it the first way. Now that we have the probability distribution table, you could do the X times the P of X and add these all up, and that would also get you the expected value. It would work out the same way, but it is quicker to do it this RA over N. It spells the word ran, if you need to remember it. So R is the number of trials. So that's the number of things that we're selecting. So in this case, it was 6 jurors. A is the number of successful options. So that's the number of possible things that we wanted to choose from. So in our case, we wanted women, and there was 10 women. So there's 10 different positive items to choose from. And then on the bottom, N is the total number of possible options, and there's 18 people. Okay, and if we work this out, we will get what the expected value is. So the expected number of women to serve on the jury would be 3.3 women on average. Okay, and it doesn't matter that it's a decimal when it's people, because expected value doesn't mean actually what you're getting. It means in the long run, over the course of a long period, on average, what would you expect to get? So 3 1/3 roughly. Okay. And it makes sense that over half the jury would be expected to be female, since there was 10 females versus 8 males. So there's more females, so you would expect on average more than half the jury to be female. So here's our next example. You're going to randomly select 4 people from a room filled with 5 grade 9s, 8 grade 10s, 2 grade 11s, and 7 grade 12s. How many grade 12s would you expect to select? Okay, so once again, let's make sure that we know that this is hypergeometric. Okay, you are selecting a specific number of people out of a specific number of people in the room. Okay, the people in the room would be N, and there is 5 plus 8 plus 2 plus 7. Okay. So there is a number of trials. You do have a probability of success or failure, right? You have a probability of getting a grade 12 or not getting a grade 12. And as soon as you've selected one grade 12, your probability of getting another one changes. So that means it is dependent. So it is hypergeometric. So once again, they're asking us how many grade 12s would you expect? So we're going to use the expected value formula. So remember, R is the number of things that you want. So there's 4 people that you were selecting, so that's how many items you wanted. A is the number of possible sort of positive items that you wanted. In this case, grade 12s was what you wanted. So A would be the number of grade 12s that you could have chosen from, and there were 7 of them. And N is the total number of people, of which there are 22. So if you work this out, you would get the expected number of grade 12s. So you'd expect to get 1.3 grade 12s. If you selected 4 people. Okay. So that was our last example. Here I just have a little probability distribution summary table. Okay. So once again, we've done the general one, which isn't on this table because it's just you calculate all the possible outcomes. or the probability of all possible outcomes, I should say. But we did learn 3 different types. We learned uniform, which is where the probabilities are all the same. That's how you know you have it. There was no special expected value formula, so we just wrote the general one out. And the probability was always 1 over n, where n was the number of outcomes. Because remember, the probability is always evenly divided. We learned about binomials yesterday. So that's where it's independent events, a specific number of trials, and success or failure. Okay, and we have a formula for both calculating the probabilities and calculating the expected values. Geometric, that is one that involves wait times. We did not do this one, so we will skip that. And hypergeometric is the last one that we did. So once again, there's a specific number of trials, you have a success or failure, but the probability of success or failure will change after every trial. Okay, so once again, there's a formula for the probability that you can use or not use, and there's a formula for the expected value. Okay, so that's a little summary table of what we have learned in this unit.